Hello everyone. In this video, we'll be implementing one amazing project with the help of Hugging Face called Text Summarization. So as of now, I showed you the Hugging Face demo, like how we can use this Hugging Face platform, how we can access different model, even how we can also fine tune those are the model on top of our custom data. So in this video, we'll be using the same technique and we'll be implementing one project called Text Summarization. Okay. So here is the notebook, guys. I already prepared. So the first thing what you have to do, first thing, just connect the notebook and make sure you change the runtime to the GPU, because here you need the GPU if you want to, let's say, implement this project, because here we'll be fine tuning one transformer based model. Okay, we'll be fine tuning one LM model here on top of our custom data. I'll tell you which model we're gonna fine tune, even on top of which dataset actually we're going to fine tune. But first of all, let me tell you what is text summarization. Text summarization means, let's say you are having a bigger paragraph and you are summarizing that particular paragraph. I think you know, okay, what is the summary, right? What is the text summarization project? So in internet, actually, you will be getting different summarization actually application. Let's say if I write text summarization online. So there are so many application you will see. This is another application from Quillbot actually. So here actually you can also give any kinds of text and it will give you the summary. So let me show you. If I search for English story, so what I can do, I can copy this text as of now as it is, and here let me paste it. Now if I click on summarize button, you will see that it will give me the summary of the entire text. Now you can also control like how much summary you need. So let's say I need a little bit bigger summary. Now if I again re-summarize, now see this result I'm getting, this is the actually a little bit long than our previous summary. Okay, so that's how actually we're having different application over the internet. So we'll be implementing this kinds of project, but here I'm not going to implement a user interface. User interface wise we'll be implementing later on. So as of now, we'll be only doing the experiment on the Colab notebook. Okay, we'll be using transformer based model, we'll be using LM model, and we'll be doing this kinds of project. Okay, this is the main objective here. So let me get back to my Colab notebook, and first of all let me execute this command. So this command will show you which GPU actually you are using. So here I'm using Tesla T4 GPU because here I'm using free Google Colab. Now the first thing what you have to do, you have to install transformer library. Okay, why? Because here we'll be using Hugging Face actually platform, and to use Hugging Face platform I already showed you, you have to install transformer library. Apart from that, you need some additional package like sentence pieces. Okay, then you need Scareblue, then row score, okay, and Pi7Zer and datasets. Why dataset? Because with the help of datasets we'll be downloading the dataset from the Hugging Face itself. Okay, that is why. And these are the dependency packages you also need to install here. Fine, so let me install all the packages one by one. So my installation is completed. So the next thing what you have to do, you have to update some of the packages. The first package you have to update called Accelerate. Then you have to uninstall your older version of Transformer and Accelerate, and you have to install the latest one, because what happens actually in Google Colab, sometimes they're using older version of the Transformer package and Accelerate package. Okay, so that's why I'm updating it again. Okay, that's the things you have to do. And what is Accelerate? See, Accelerate will help you actually to access your GPU. That means here you are using GPU, you are using something called CUDA. Okay, so to use your CUDA actually instance, this Accelerate will help you. So whenever it will do the fine-tune operation, that time actually it will access your GPU, right? So that's why actually this package is required. Now let me update all of them. So as you can see, update is successful. There is no error. That means everything is working fine. Now the next thing, you have to import some of the necessary library to test whether everything is working fine or not. So here you can see I'm importing pipeline. Then I'm also importing load dataset from the dataset. Okay. And apart from that, I'm also importing some additional library. Okay, some extra library also I'm importing here. It is not required, but what the library actually I'm going to use like later on I'll tell you, okay, why I'm using that one. So as of now, let me import all of them. See, this execution is fine. That means there is no error. We have successfully installed all the packages. Now I think I already imported Torch, so I don't need to import this line. I can delete. Now the first thing what I have to do, I have to check the device, okay, whether it is utilizing my CUDA or whether it is utilizing my CPU. So as I already showed you, I have changed my runtime to the GPU, right? And here you can see it is connected with my T4 GPU. That means it should use my CUDA. So let me check. See, it is utilizing my CUDA. So here I'm using Torch, PyTorch library to check it whether CUDA is available or not. If yes, print CUDA, otherwise print CPU. So you don't need to manually set your machine type. So if you have the like GPU installed in your system, and if all the tools and let's say services are already installed, so it will utilize that particular GPU, that means your CUDA, otherwise it will automatically utilize your CPU. Okay, so if you see any kinds of PyTorch implementation, PyTorch use this particular code snippet, okay, to map with your CUDA or with your CPU. I hope it is clear. Now the first thing what I have to do, I have to load my Tokenizer. Okay, Tokenizer. And what is Tokenizer? I already explained. With the help of Tokenizer, we'll be preprocessing our data, and I will be converting my text to vector representation. So for this, I'm going to import auto tokenizer from transformer library, and another class I have imported auto model for sequence to sequence LM, because here we'll be loading one LM model. That means we'll be loading one transformer based model. And to load the transformer based model, actually you have to use this particular class. Fine. Now let me import this package. Now here is the model checkpoint, guys. So here we'll be using one model called Google Pegasus CNN Daily Mail. Okay, so this is the transformer based pre-trained model, and this is the model, guys. This is from Google. So Google has trained this model, and this model can perform text summarization. Okay, now if you want to test it, here is the inference API. Now here you can see it will give you the summary. Okay, summary of the entire text. Now you can see like what kinds of data set they use to train this model. Every information they have given, okay, about the model. So if you're interested to deep dive, you can check this documentation. You can check this model cut. You will see each and every details. Now if you want to see the model, just click on files and version. You will see the GB of the model. It is around 2.28 GB, and there is another file, it is around 3 GB. Okay, so total I think 5 to 6 GB this particular model. So whenever I will download this model, you will see that, okay, what is the like model size as of now. Let's get back. So now let's load the Tokenizer, and I already told you the model actually will be using the same model you have to use for the tokenization as well. Fine, this is the idea. Now let me load the Tokenizer. So for this, I'm using auto tokenizer from pre-train, and here I'm giving the model checkpoint. It will automatically download from the Hugging Face itself. So fine, I have already downloaded the Tokenizer. Now we'll be downloading the model. Okay, so to download the model, I'll be using this class auto model for sequence to sequence LM, this class, and there is a function called from pre-train. You have to give the model checkpoint and to device, like in which device you want to load the model. I want to load the model inside my GPU. Okay, that's why I'm giving GPU to device is equal to my device. Now let me load it. Okay, my model has also loaded. Now we'll be loading the dataset, and dataset wise we'll be using one dataset named Samsung dataset. So this is the dataset, guys. So this dataset is from Samsung actually. So they have published this data. And the Samsung data is nothing but it's a dataset containing about 16K messenger like conversation with summaries. That means it is having actually different conversation. Okay, and in the another column actually it is having the summaries, okay, of that particular, let's say, conversation. So if I show you, let's say this is the conversation. Okay, this side you are having the conversation, and this side you are having the summary. So let's say this is the conversation, and this is the summary. Okay, again this is the conversation, this is the summary. So that's how they have collected the entire data, and it is having 16K actually messenger like conversation data. Fine, and the dataset name is Samsung data. And if you want to see the dataset is split, so it is having around 14,732 example for the training, validation that many example, and testing that many example. Fine. So again you can see this documentation if you want to learn more about this data. Now let's download the data. So for this I'll be using load dataset from my dataset package. Now let me download the data as well. Now I'll give yes and I'll press enter. It should download the data. Okay, now if I show you the dataset metadata. So this is the metadata, guys. So as I already told you, it is having a dialogue and summary, and that many of example you are having for the training, testing, and validation. Fine. Now if you want to see any kinds of, let's say, dialogue, that means your entire, let's say, conversation, you can also visualize. So let me visualize one of the example. So this is the dialogue, guys. You can see Olivia is telling who are you voting for this election. Then Olivia is saying liberal as well, and Olivia, me too. Olivia, great. Okay, so this kinds of conversation it is having, and based on that it is having one summary. So let me also show you the summary. So I'm printing the summary here. You can see, so Olivia and Oliver are voting for the liberals in the in this election. Okay, so this kinds of actually data set they have prepared. Now this particular code snippet will print the number of example you are having in this data set, as well as the split length and the, let's say, entire dialog and entire summary. Now let me show you. See, this is the split length, this is the training, validation and testing, and these are the features it is having, like ID, dialog and summary, and this is the entire dialog you can see. Okay, and this is the summary of the dialog. So this is the preview of the data, that's why I just printed. I just wanted to show you, okay, what kinds of data they collected. Now let's say you are having some different kinds of data. So what you can do, you can give your, let's say, entire, let's say, paragraph as a dialogue and the summary as a summary. Okay, and you can follow the same approach. Okay, it doesn't matter. Now the next thing what I have to do, guys, I think you remember, I have to pre-process my data and convert to the vector representation. So for this, what I have to use my tokenizer. Okay, I think you know. And on top of which actually, let's say, column I have to apply my tokenizer on that dialog, because dialog is my actually paragraph. And again, if you see the summary is also a text. Okay, so I also need to apply the tokenizer on top of the summary as well. So here I've written a function convert example to features. So it will take the example batches, that means your dialog and summary, and it will perform the tokenization operation. You can see. So first of all, I'm applying tokenization on top of my dialog. Then I'm applying tokenization on top of my summary. Then whatever results actually I'm getting, I'm just returning. That means you will get input IDs, attention mask, as well as the labels. I think I showed you. Okay, from that example. Now let me execute. And now let me map this function on top of my entire data set. Okay, so see here I'm doing the map operation. Now first of all, let me convert to vectorization, then I will show you, okay, how it will look like. So see, execution is done. Now if I show you my data set right now, see it is having different features: ID, dialog, summary, input IDs, attention mask and labels. Okay, because I converted to the vector representation right now. Now if you want to see the input IDs, so this is nothing but your input IDs. That means this is the vector representation of the first dialog. Okay, and if you want to see the attention mask, you can also print the attention mask. So this is the attention mask. That means it is giving all the word as the same attention. I already explained this part. Fine. And if you want to print the label as well, that means the summary, you can also print it. Let me show you. So here I will print the labels. So this is the labels. Okay, that means this is the summary of this dialog. Fine. I hope it is clear. Now we'll start the training, but before that, what I have to do, I have to set some training arguments. I think you remember, right? But before that, one thing you have to do, if you're using a large amount of data, so you have to initiate this data collator. Okay, so what data collator will do? Data collator will help you to load your data as a batches in the memory. See, here you are having so many examples I showed you in the training, validation and testing. So I don't need to load the entire data in my memory, because here if you see my memory size, I got actually 12 GB RAM. So if you are having huge amount of data, so 12 GB RAM is not enough. So for this, what you can do, you can load your data as a batches. That means some amount of data will be loading, you will be training, again you will be taking another batches, again you will be training. That's how you can perform the operation. So this data collator will help you to load your data as a batches. And if you want to define the data collator, you have to use this class from transformer, data collator for sequence to sequence. So here you can see I'm passing my tokenizer and model inside the data collator. Fine. Then you have to initialize this data collator object. So let me initialize it right now. Now the same thing, you have to set the training arguments. So as I already told you, just keep all the arguments as same. No need to change anything. Only you can change the number of epoch. Okay, you will be training. So as of now, I'll be showing you only one epoch training because again, it will take time. We are using free Google Colab. Okay, and the output directory I want to create Pegasus Samsung. Okay, so it will create our output directory Pegasus Samsung. Inside that, it will save all the artifacts. Fine. So let me initialize the argument as well. Then I will initialize my trainer object. So it will take the model, your training argument, tokenizer, data collator, and you have to pass the training data. Now see here, one small hack actually I'm doing. See, if you see the training data size, it's very huge. So as I already showed you here. So that many training example, it is having almost 15,000. So if I'm taking 15,000 data for the training, it will take lots of time. And this is my validation and testing. So what I'm doing actually, instead of taking the training data, I used actually test data as my training data, because inside test data, I'm having very less example. So that I want to show you the quick training. But if you are training actually, okay, if you are doing the actual training, that time you just use train data. Okay, not the test data. So this is the hack, guys, small hack I'm doing, because if you want to experiment something and you don't have that much of time, so you can take a small amount of data and you can perform the, let's say, experiment. Okay, so that is what actually you can perform. And here you can see evaluation data. I'm giving my validation data. It's completely fine. Okay, now let me initialize my trainer. Now if you want to start the training, you have to call trainer.train. Now it will start the training of the model. So it will take some time, so I will pause the video, and once training is completed, I will come back. Okay, so my training is completed. Now here you can see my training losses and different metrics that it is giving, but you have to check the training losses. So this loss should be close to 0, guys. Okay, if it is close to 0, that means your model is performing well. Now if you want to evaluate this model on top of the test data, you have to use this function, calculate metrics on test DS. Okay, so here you will be calculating something called row score. Okay, what is row score? See, row score is a metrics for the summarization model. Take summarization model. You can search on Google. You will find the row score actually equation. But as of now, I won't suggest, don't deep dive into the equation. Just try to consider it just a evaluation metrics. Like for the classification, actually what evaluation metrics we used to use, like accuracy score. Then we used to use confusion metrics, AUC curve, right? And here we are performing something called text summarization, and text summarization uses one metric called row score if you want to evaluate that model. So similar wise, for language translation, we use another kinds of metrics. For, let's say, name entity recognition, we use another kinds of metrics. For, let's say, conversational agents, we use another kinds of metrics. Okay, all kinds of tasks is having their different evaluation metrics. Okay, this is the main idea here. Now before that, let me show you the models actually it has trained. Now inside Pegasus Samsung folder, this is the checkpoints. Inside that you can see this is the model actually it has trained. Now we'll be saving this model as well. So just let me first of all show you the evaluation metrics, then I will say tell you how we can save the model. And now you can ask me where I got this function. See, if you just go to the Hugging Face that documentation, go to the text summarization task, you will see that they are suggesting this function. Okay, so they're suggesting if you want to perform the evaluation on top of the, let's say, your text summarization model, you can use this row score function. Okay, this is the idea. Now here we'll be calculating our row score. So here you are having actually 4 kinds of row, like row 1, row 2, row large, and row L sum. Okay, now let me calculate the row score. First of all, I will be loading all the row matrices. I have to give yes. Then I will be calculating the score on top of my testing data. Okay, now let me execute. And again, I'm only taking 10 example, guys, because it is having actually lots of data and it will take time. That's why I have taken only 10 example. But if you are performing actually, so but you can remove this line. That means you are performing on top of the entire data right now. Fine. This is the small hack you can follow if you're doing the experiment only. Now see, guys, this is my row score I got. Now guys, you can see I got the row score, and this row score should be close to 1. Okay, if it is close to 1, that means your model is performing better. So as of now, we used our test data for the training and we only trained one epoch. That's why this row score is not good. Okay, but if you're using actual training data and if you train multiple epochs, you will see that you will get a good row score here. Fine. Now let's save the model, my Pegasus model. So I'm using save pretrain function, and here I'm giving the name, so it will save my model. So now if I refresh, you can see my model has saved. So this is my model, Pegasus model, my trained Pegasus model. Then I also need to save my tokenizer, because later on I will be giving my let's say testing data, and if I want to do the, let's say, summarization task, that time it will also convert that data to the vector representation. Now see, this is my tokenizer. I also save. Fine. Now if you want to load any kinds of pretrain tokenizer, what you can do, you can use auto tokenizer from pretrain. Now you can give your tokenizer location. Okay, now see, here I'm giving my tokenizer location, not the tokenizer we downloaded from the Hugging Face. Okay, now let me load my tokenizer. So this is my custom tokenizer right now. Now this is the prediction code. Okay, now to perform the prediction, first of all, you have to generate some arguments. Now you have to set a length penalty, then number of beams, then max length. So you don't need to change this parameter, just keep it as it is. Only you can change this length penalty. What is length penalty? I think you remember. So here we had one, let's say, interface, like we can generate short output, we can generate long output. Now if this parameter is close to 1, that means it will generate actually long output. If it is close to, let's say, 0, it will generate short output. Okay, this is the idea. Now here you can see I'm taking a sample text from my test data. I'm taking actually dialog 1, the first dialog. Okay, you can see from the testing data, I'm picking up the first dialog. Let me show you. So if I execute it here, so this is the first dialog I'm taking from my test data, and I'm also taking the reference, that means the actual summary of it, because I want to match this summary with my actual prediction of my model. This is the actual summary, right? Then what I'm doing, I'm creating a pipeline. I think you know what is pipeline in Hugging Face. And here I'm telling I want to perform summarization right now. And I want to use my model, the model I trained. So this is the model I trained. I'm giving the name of the model. You can see, okay, Pegasus Samsung model. And here I am passing my tokenizer. The tokenizer actually I loaded here. Fine. Then I'm creating the pipeline. Now here I'm printing my sample text. That means the text actually we have loaded this first dialog as well as the reference. That means my actual summary. Then I'm predicting my model. You can see I'm passing this sample text to my pipe object, okay, my pipeline. And here I'm giving all the parameter I set here, okay. Then whatever output I'm getting, I'm only printing the summary text of it. Now let me show you. If I execute this code, see, this is my actual dialog. This is my actual summary. Now my model is predicting, okay, the prediction summary. Let's wait and let's try to match, okay, how much accurate it is. Now see guys, I got the prediction. Now just try to see. Now you can see this is the model summary. That means my model has given me the summary. Now see, it's not very accurate, but still it is close to, because again I told you we only trained one epoch and we used our testing data for the training. Okay, that is why it is actually not, it is not giving actually good performance. Okay, and if you want to increase the performance, what you can do, you can increase the epoch size and you can test, and you have to train on top of the training data, okay, not on top of the test data. Okay, this is the small modification you can apply. So I hope guys it makes sense right now how we can actually implement different projects with the help of Hugging Face platform now. Okay, that means I showed you how we can use different model, whether it can be LM model, whether it can be LLM model, how we can use different data sets, okay, and how you can use the Hugging Face pipeline, okay, to create your application. So this was my main objective, the proper use of Hugging Face, okay, because going forward we'll be utilizing this particular, let's say, technique only to perform all of the, let's say, project, okay, whatever project we'll be doing, we'll be following this particular approach only. And going forward I will be also showing you how we can use large language models. So see, now we are using LM model only, okay, language model only, but going forward we'll be using large language model. That means we'll be using llama model, okay, we'll be using llama model from Meta, we'll be using, let's say, Mistral model, okay, we'll be using Falcon model, different like large language model we'll be exploring. Okay, so I hope guys this is clear now how we can perform this text summarization project. Now one task I want to give you, see, I already told you now we are having different data sets in the Hugging Face. So you can select based on the task. Let's say if I go to the task, let's say I want to perform summarization, I'll click the summarization. Now see, these are the data related summarization. Now what you can do, you can pick up any kinds of data set from here, okay, and you can perform that text summarization on top of the data. See, here I used Samsung data, but I want you to use some any other data. Okay, so please try to attempt this task, because unless and until you are not doing like a practical from your side, it would be a little bit difficult for you. So with that guys, thank you so much for watching this video, and I will see you next time.